All right, so now this is page 463, part 2. And the first one here wants us to take this region, x equal y squared, the line x equal 4, and spin it around the line x equals 6. So let's get a visual on that. X equal y squared looks kind of like this. It's a parabola turned on its side. If we go out to x equal 4, we get this right here. So we're looking at this region right here. When x is 4, y will be either 2 or negative 2. So it looks kind of like this. We're out here at 4. So this point right here is 4 comma 2. This point right here is 4 negative 2. Okay? But now we're going to take it and we're going to spin it around the line x equals 6. So we're going to go to 6 here and spin it. So as we spin it, go from the axis out to the outer edge. This is your big radius right here. And we need an expression for that. That's going to create this big circle around. So 6 represents the distance from x-axis out to here. This part is y squared. This little part right here is y squared. So the big radius that we want is 6 minus y squared. If I go pi times that squared and we integrate that from negative 2 to 2, that would give us everything, okay? As if this whole thing was a solid. But not the whole thing is a solid. We have a piece that's missing, and the piece that's missing is from here to there. And no matter what y value you're at, that distance is always 2. Okay. So there's our setup. We have our big radius squared minus our little radius squared. So now we take our calculator and go pi math 9 from negative 2 to 2. And we're going to go parentheses 6 minus x squared in parentheses squared minus 2 squared. dy. Well, and we get a value of 241.274. That'd be our answer there. So first off, we had to get a visual on that, which isn't easy, and then set that part up. All right. The rest of these aren't going to be too bad. So 28 says, what if we had this y equal e to the x over 2? So if I graph that, if I put 0 in there, I get e to the 0, which is 1, and then it's going to become an exponential, so it's going to look something like this. And we're going to go all the way out to x equal 4 with that. So x equals 0 right there, x equal 4 is right here, and y equals 0 is the x-axis. So here's our region. And we're spinning it around the x-axis. So as you spin it, you create these solid discs in here. And so we're going to go ahead and use that disc method to help us figure this out. So we'll have the integral from 0 to 4 of e to the x over 2 squared, pi times that, and then dx. Okay. And so we can put that right on a calculator and see what that equals. So if I go pi and then math 9 from 0 to 4, we can go e to the x divided by 2, and then parenthesis on this. Actually, let me delete that. Let's get a parenthesis on that, and then a parenthesis at the end and square it, dx. Now, some of you might say, well, did you need to do that? You know, e to the x over 2 squared would just be e to the x. And yes, we could have done that, but some of us see that, some of us don't. Wanted to show you, all stretched out. We get 168.384. 168.384. That's our answer there. For 37, we're graphing the natural log function now. So natural log kind of looks like this. And we're doing that y equals 0, so that's the x-axis. X equal 1, that's when it first hits there, because natural log of 1 is 0. And then out to 3. So out to this value here. We're taking this, and we're spinning that around the x-axis. So again, not too bad. This is natural log of x is the radius, is the radii that come out. So it'll be pi times natural log of x squared, and we're doing that from 1 to 3. Okay. So I take the calculator and we go pi math 9 from 1 to 3 parentheses natural log of x squared dx. And we get 3.233 for our answer there. Yeah, not too bad. 53 gives us this kind of function, and they say we're spinning around the x-axis, and they want to know what the volume would be. If you look at the original picture of it again, it does go from 0 to 2, so this is, again, a pretty easy setup. We're going to go pi times from 0 to 2, this 1/8 x squared square root of 2 minus x squared dx. It's really more just about putting it on the calculator correctly, right? So if I go pi and then math 9 from 0 to 2, parenthesis 1/8 times x squared times the square root of 2 minus x, end that one, okay? Close all of that up and square it, and then dx. We should end up with 0.105. So not very much. That's what we get there. All right, then 62 gives us a chance to try the cross-section area. So x squared plus y squared equal 4 is a circle with a radius of 2. That's the definition of it, okay? If I slice it, though, at some point, what they're saying is that imagine there's a solid coming up out of the paper at us, and when you cut that at some random x value and you open it up, what you're going to be looking at is a square, okay? And the base of that square will be this length right here. So we need an expression for that length. So to get that, I'm going to solve this for y. Y is the height here. So if I solve this for y, I get y equal to the square root of 4 minus x squared. Now that would be just this length, but I really want the entire thing. I'm going from here down to here. So that's going to double it. This length here is 2 times 4 minus x squared in square root. Okay? And so the area of this square would be that length, 2 square roots of 4 minus x squared, squared. The volume would be that times dx. So if I do 2 square root 4 minus x squared squared dx, now I've got a volume for that little disk that I pulled out of there, and I'm going to integrate all of those from -2 to 2. And that'll give me the full volume. I don't need a pi. We're not spinning anything. We're not creating any circles. It's just simply from -2 to 2, this value, 2 square root of 4 minus x squared squared. We could do some simplifying if we wanted to, but this will get the job done. We should get 42.667 as our answer there.